Is time travel possible? According to the science, yes it is. We all travel in time. We are traveling in time at approximately the same speed, 1 second per second. However, when we think of the phrase time travel, we are usually thinking of traveling faster than 1 second per second. That kind of time travel sounds like something you'd only see in movies or science fiction books. Could it be real? Science says yes. More than 100 years ago, a famous scientist named Albert Einstein came up with an idea about how time works. He called it relativity. This theory says that time and space are linked together. Einstein also said our universe has a speed limit. Nothing can travel faster than the speed of light. What does this mean for time travel? Well, according to this theory, the faster you travel, the slower you experience time. Scientists have done some experiments to show that this is true. For example, there was an experiment that used 2 clocks set to the exact same time. One clock stayed on Earth, while the other flew in an airplane, going in the same direction Earth rotates. After the airplane flew around the world, scientists compared the 2 clocks. The clock on the fast-moving airplane was slightly behind the clock on the ground. So, the clock on the airplane was traveling slightly slower in time than 1 second per second. We can't use a time machine to travel hundreds of years into the past or future. That kind of time travel only happens in books and movies. But the concept of time travel has always captured the imagination of physicists and laypersons alike. But is it really possible? Of course it is. We're doing it right now, aren't we? But that was not what you were thinking. Can we travel much further into the future? Absolutely. If we could travel close to the speed of light, or in the proximity of a black hole, time would slow down, enabling us to travel arbitrarily far into the future. The really interesting question is whether we can travel back into the past. Einstein's general theory of relativity allows for the possibility of warping time to such a high degree that it actually folds upon itself, resulting in a time loop. Imagine you're traveling along this loop. That means that at some point, you'd end up at a moment in the past and begin experiencing the same moments since, all over again, a bit like deja vu, except you wouldn't realize it. Such constructs are often referred to as closed time-like curves, or CTCs in the research literature, and popularly referred to as time machines. Time machines are a byproduct of effective faster-than-light travel schemes, and understanding them can improve our understanding of how the universe works. Over the past few decades, well-known physicists like Kip Thorne and Stephen Hawking produced seminal work on models related to time machines. The general conclusion that has emerged from previous research, including Thorne's and Hawking's, is that nature forbids time loops. It essentially says that nature doesn't allow for changes to its past history, thus sparing us from the paradoxes that can emerge if time travel were possible. The most well-known amongst these paradoxes that emerge due to time travel into the past is the so-called grandfather paradox, in which a traveler goes back into the past and murders his own grandfather. This alters the course of history in a way that a contradiction emerges: the traveler was never born and therefore cannot exist. There have been many movie and novel plots based on the paradoxes that result from time travel, some of the most popular ones being the Back to the Future movies and Groundhog Day. Depending on the details, different physical phenomena may intervene to prevent closed time-like curves from developing in physical systems. The most common is the requirement for a particular type of exotic matter that must be present in order for a time loop to exist. Loosely speaking, exotic matter is matter that has negative mass. The problem is negative mass is not known to exist in nature. Another model that does not require exotic matter is Mallory's model. Mallory's model consists of 2 super long cars, built of material that is not exotic, and have positive mass, parked in parallel. One car moves forward rapidly, leaving the other parked. Mallory was able to show that in such a setup, a time loop can be found in the space between the cars. So can you build this in your backyard? If you suspect there is a catch, you are correct. Mallory's model requires that the center of each car has infinite density. That means they contain objects, called singularities, with an infinite density, temperature and pressure. Moreover, unlike singularities that are present in the interior of black holes, which makes them totally inaccessible from the outside, the singularities in Mallory's model are completely bare and observable, and therefore have true physical effects. Physicists don't expect such peculiar objects to exist in nature either. So, unfortunately, a time machine is not going to be available anytime soon. However, this work shows that physicists may have to refine their ideas about why closed time-like curves are forbidden.